Homework 8, question 2. So, question is, let n be a Poisson process with a parameter lambda that is a probability of n, the number of the random points arrived in t1, t2 equals to k equals to e to the negative lambda of t2 minus t1 times the lambda times t2 minus t1 to the k over k factorial. So now we define a new stochastic process with x of t is equal to 1 if n is odd in 0 and t, and is equal to negative 1 if n is even in 0 and t. So A, find the probability of x of t equals to 1. So we know that E of lambda t is equal to 1 plus lambda t plus lambda t to the square over 2 factorial plus lambda t to the third over 3 factorial, and so on. And we know that E of negative lambda t is going to be equal to 1 minus lambda t plus lambda t to the square over 2 factorial minus the lambda t to the third over 3 factorial plus lambda t to the fourth over 4 factorial, and so on. So when as we can see from the pictures, that we name the first one first equation and we name the second one second equation. So using the first equation minus the second one, we get is it going to be equal to e times lambda t minus the e to the negative lambda t, and then we do the calculations, we can get that. So the 1 minus e to the negative 2 lambda t over 2 is going to be equal to e to the negative lambda t times the lambda t plus lambda t 3 to the third over 3 factorial plus lambda t to the fifth over 5 factorial, and so on. So the probability of x of t is going to be equal to 1. Is going to be equal to probability of that in 0 and t that the k is odd, and it's going to be equal to the summation of when k is equal to odd e of negative lambda t times lambda t to the k over k factorial, and then it's going to be equal to 1 minus e to the negative 2 lambda t over 2. And we plus, we're using the first equation and second equation, we plus them together, we get that e of lambda t is plus the e of negative lambda t is going to be equal to 2 times times 2 times 1 plus lambda t to the square over 2 factorial plus lambda t to the fourth over 4 factorial, and so on. So the probability of x of t equal to negative 1 is going to be equal to probability of that in the case even one in internal of the 0 to t, and it's going to be equal to the summation of the k when k is even, the e to the negative lambda t times lambda t to the k over k factorial. So it's going to be equal to 1 plus e to the negative 2 lambda t over 2. So question is asking, trying to find the e of x of t. So we know that e of x of t is going to be just equal to 1 times the probability of x t equal to 1 plus the negative 1 times the probability of when x of t equal to negative 1. So as we know from the earlier calculation, we get that it's going to be equal to 1 over 2 times e times 1 minus e to the negative 2 lambda t minus 1 over 2 times 1 plus the e to the negative 2 lambda t is going to be equal to the negative e to the negative 2 lambda t. So C, find R1 RT, R1 RT1 RT2. So RT1 and RT2 is going to be equal to the e of xt1 times xt2, and then it's going to be equal to 1 plus 1 times probability of xt1 times xt2 equals to 1, plus -1 times the probability of xt1 xt2 equals to -1. And then we do the calculation. We get that is going to be equal to e to the -2 lambda t2 minus t1, and so the rt1 t2 is equal to e to the lambda to the -2 pi 2 lambda t1 minus t2. So for D, is x of t y stands stationary? Yes, x of t is a WSS.